Okay, in this video, what I'm going to show you is how to take the information from the summer jobs problem that we worked on in class and input that information into Excel and run solver to find the optimal solution. So the first thing I'm going to want to do is come over to Excel, and in the top left I'm going to type in some information so that when I come back to this spreadsheet later I'll know what it is I've written up. So I'm going to call this one summer jobs, and I'll write in that it's for AFM. And now the first thing that I'm going to want to put in are my decision variables. So on the left hand side, pretty much in all of column A, we're just going to be putting in labels so that we know what's happening in the rest of the spreadsheet. Okay? So if we go back to our information, we see that our two decision variables are x1, which is weekly hours worked doing dishes, and x2, weekly hours worked mowing lawns. So I'll come over to my spreadsheet, and for this one I'll type in, I'm just going to use shorthand and say dishes to save space, and that's x1. And then this one I'll type in lawn, and that's x2. Okay, so these are my decision variables. Now I need some space to store the actual values that these decision variables can take on. And so we add another line called decision values. And the units on this are going to be weekly hours. And I put this here simply so that, like I said, when I come back to this spreadsheet, I'll remember what the units are on my decision variables. Now, we don't have any information about this yet. What I am going to do is I'm going to highlight those and give them a color so that I remember where they are and I can see them easily, because we're going to come back to these cells often. Okay, next what we have to do is define our objective function. And if we look, our objective function is going to be 7x1 plus 10x2, and we found that in our write-up by seeing that for every hour we work mowing lawns we earn $10, and for every hour we work washing dishes we earn $7. So I'm going to come over here, and what I want to use these cells for is the coefficients for our objective function. So in this case, column B, everything we put in column B should have something to do with washing dishes. And everything we put in column C should have something to do with mowing lawns. So we know we earn $7 for every hour we work washing dishes, and we earn $10 for every hour we work mowing the lawn. Okay, and so as you can see, the 7 is in the same column as our dishes constraint, and the 10 is in the same column as our lawn constraint. So in this cell here, and I'm going to give this a new color, we're going to compute our total profit. And so I will give that cell a title as well. And so what we want to do is we're going to take this function here, and we're going to translate that so that Excel understands it and can compute it. Okay? So we're going to come back to our spreadsheet, and I'm going to type equals, because the equals sign tells Excel that there's a formula coming and it should do some work. Okay, and now our formula is 7x1 plus 10x2. All right, so we need to figure out a way to tell Excel to do that. So what we're going to do is we're going to click on the cell that has our coefficient, and we're going to multiply that by the cell that's holding our variable. And in the Excel spreadsheet, we're treating this empty cell here under dishes x1 as our variable. And we're going to add to that 10, so we click on the cell that has our 10 and multiply that by the cell that's holding x2, which is this empty cell here. So essentially what you can see is that our old formula of 7x1 plus 10x2 has been replaced by B7, which holds 7, times B5, which is our new x1 as far as Excel is concerned, plus C7, 10, times C5, which is our new x2. So when I hit return, that will be 0, because we don't have any values here for our decision variables. Now if I were to put a 1 here, that means I'm going to work 1 hour doing dishes. So you should expect that our profit should be $7, because that's how much we earn for every hour we work doing dishes. And sure enough, Excel we have our formula correct so that Excel knows that our total profit for 1 hour of washing dishes is $7. And then similarly, if we type in a 2, you can see our profit jumps to 17. So that we can see that formula is working correctly. So the last thing we need to do to set up our spreadsheet is add in our constraints. So I'm going to type in constraints so that I know what's coming next. We'll have to do with constraints. Now we have this constraint here, x1 plus x2 is less than or equal to 20. And if we remember, that constraint came from the total number of hours we wanted to work per week at maximum. So I'm going to type in maximum hours here for this constraint. Now, when we want to input this into Excel, remember, we already have our variables. So we have the x1 and the x2 available to us. Remember, we're storing them here in these two cells. What we need here are the coefficients. And if we look, our coefficients here are 1 and 1. So we don't normally write them, but you can think of that there's a 1 multiplied by the x1 and a 1 multiplied by the x2. So I'm just going to type 1s in for each of these cells. All right, now in this cell, what we want to do is we want to compute this left side of the constraint because that's what we want to know the value of. So I'm going to give this cell a different color, and in this cell I'm going to compute that constraint. So it's going to be again equals, and what we should have is x1 plus x2. Well, what I really need is I want to make sure I'm using my coefficient, so I'll just type in, I'll click in the cell that has the 1. I'm going to multiply it by our the place where we're holding our variable, which again, remember, is where we shaded yellow. I'm going to add to that 1 times x2, and I'll hit return. So again, we have a 0, but if I put a 1 and a 1, you can see the hours I've worked should be 1 and 1. Added together, we get 2. So now our profit is $17, and we've worked 2 hours. All right? So again, I'll take those out. Just wanted to show you that those formulas are working. Our second constraint had to do with the fact that to keep our dishwashing job, we had a minimum amount of hours to work at our dishwashing job. And so we translated that as x1 is less than or equal to 5. Well, now we need to translate that again for Excel. So I'm going to call this minimum dishwashing constraint. Now the dishwashing constraint should be x1 is greater than or equal to 5. So x2 is not involved. So the coefficient there is actually 0. And since we look, we have no coefficient here. That's an implicit 1. I'm going to put the 1 there. All right, and now I want to compute that, and I'm going to do that just like I did before. It's going to be equals coefficient times the variable plus the coefficient times the variable. Okay, and I'm going to color this one again. Now, we need our inequalities. So remember, we have x1 plus x2 has to be less than or equal to 20. So here's the value that inequality will take on. That has to be less than or equal to 20, and I'm just going to type those in. And again, this one has to be greater than or equal to 5. And so this was actually the one that was wrong that we fixed in class. So when I type it in here, I'm going to want that to be greater than or equal to 5. So now that we have our formulas and we have our we have our constraints all set up, we're ready to run Solver. Okay, so what I'm going to do is, this is a little different on my version of Excel and my version of Solver because I'm on the Mac, but it should be fairly similar to what you have done. Okay, so I'm going to set my target cell. My target cell should always be my objective function. And remember, we computed our objective function in the green cell. So this is why we highlight them so that when we run Solver, we can see them. By changing cells, so in this section, we want to put our decision variables, because those are the cells we want Excel to change in order to find our optimal solution. So I'm going to click and drag so that I get both of my decision variables. If we had like a whole bunch, we just click and drag all the way through. I'll click OK, so now we have our decision variables in, and now I need to add my constraints. So my constraints are going to be the cell that we computed our formula in, the one that I highlighted purple, and that has to be, this one has to be less than or equal to, and I'm going to want that to be less than or equal to 20. So I'll click on the cell where I typed in that maximum value. Click Add, because I have another one I want to do. I want this constraint to be greater than or equal to. So you got to be careful whether you're less than or equal to or greater than or equal to make sure you change that here. And on the right hand side, I want it to be greater than or equal to 5. So now that I've added in both of my constraints, I can click OK. So you can see my target cell's good, my decision variables are good, my constraints are good. I just need to set up a few options. And these look a little different on the Mac. So I need my precision to be a little bit better. Some of you are adding in zeros. I just have to change my scientific notation here. We all need to assume a linear model, assume that it's non-negative, and use automatic scaling. So now that my options are set, my information's good, I'm ready to go ahead and solve. And so I click Solve, give Solver a minute or so to solve the problem, and it tells me that Solver has found a solution. All constraints and conditions are satisfied. I don't need any reports right now, so I'm just going to keep the Solver solution and click OK. And interpreting this, Solver has found that it's best to work just 5 hours doing dishes per week and 15 hours mowing lawns. And if I do that, I will earn $185 every week. So based on my constraints and the objective that I wanted, Solver has found the optimal solution. And so that's it for Solver. So what we've done is we've taken information given in the paragraph, we translated that into the decision variables, objective function, and our constraints using mathematical symbols. And then we took those mathematical statements and we translated them so that Excel could understand them using formulas. And once we had that, we could let Solver do all the heavy lifting of actually finding that optimal solution. Now, this is a fairly simple model, but as you will see very soon, we're going to get into some rather complex models that we are not going to want to solve by hand. And so knowing how to do this will help us solve those more complex models.